Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 4, Lesson 16, Session 2. Learning targets. Oh, actually, the lesson is called Understanding of Representing a Situation with Different Expressions. So the learning targets today will be write different expressions for the same situation, understand how different expressions provide different information about that situation. Model it. Arturo's family hires 3 painters. Each painter charges $60 per hour. Arturo's family represents the charge for X hours of painting in different ways. Arturo's mom represents the situation with the expression 60x plus 60x plus 60x. What does the 60x represent? And what does the 60 plus 60 plus 60 with the x's represent? Okay. The 60x, well, $60 per hour. The 60 is the dollars. And x is number of hours. Okay, 60 is dollars and x is the number of hours. What does the 60x plus 60x plus 60x represent? That represents the price they will pay for 3 painters. Okay, that's the price they're going to pay to 3 painters for X number of hours. If it's 1 hour, it'd be 60 plus 60 plus 60. If they took 2 hours, it'd be 120 plus 120 plus 120 because 60 times 2 is 120, etc. B says Arturo's dad represents the situation with the expression 180x. What does the 180x represent? Well, the 180 is dollars paid to 3 people or 3 painters, which are people. Okay. The X is, again, number of hours. Okay, so the mom is keeping each person separate and going to pay each person individually. Dad's just going to say, well, I'm paying $180 per hour for 3 guys, so I'll just calculate the total and let them split their money the way they like. Okay, so what information is 60x plus 60x plus 60x that is not in the 180x? Okay, well, it tells us what each painter will get. Okay. What information is the one in the 180x that is not in the 60x plus 60x plus 60x? And that would be the total amount paid. Okay, so if, for example, these 3 guys paint for 3 hours, mom's going to say, well, 3 times 60 is 180 plus 180 plus 180. So each guy gets $180, but it doesn't tell the total. But if you use dad's 180x and it's 180 times 3, then we're going to get $540. So the way dad does it, he's finding out what the total cost is. The way mom does it, she's finding out what she's going to pay each individual painter. Okay. Next problem. Arturo writes the expression 480D plus 480D plus 480D to show how much the painters charge for D days of painting. Then he writes the equivalent expression 1440D, which is 480 times 3. What information is in the 480D that's not in the 1440D? Well, in the 480D tells us what each painter makes in a day. What am I doing? Okay. And the 1440D tells what the total cost per day the painters will be. Okay, so this is telling us what each painter makes. This is going to tell us what each day costs for three painters. Okay. Number 3. Elu buys three adult and 3 child bus passes for a trip. The adults are orange, the children's passes are that blue, aqua, turquoise, whatever. The cost of an adult pass is A. The cost of a child's pass is C. Elu writes both 3 times A plus C and 3A plus 3C. Explain how each expression represents the total cost. Okay. Well, the first one, 3 times A plus C, states that each child is accompanied. Is that how you spell accompanied? Is there 1 C, 2 C's? I need to know that. Okay, so I had to check that. It just didn't. Sometimes, when you write stuff, it doesn't look right. It is 2 C's. Okay, so 3 times A plus C states that each child is accompanied by an adult. And the 3A plus 3C, oh, by the way, and there are 3 pairs. 3A plus 3C states that there are 3 adults and 3 children, and a ticket for each. Okay. Okay, part B. Elu learns that 2 more children will go on a trip. How can she modify both of these to include the cost of 2 more children passes? Okay, so for starters, if we had 3 times A plus C, the 3 represents the number of adults and children. Okay. So I cannot change this to a 5. There aren't 2 more adults. It's just 2 more children. So there's nothing I can do with this except add 2 children to the end of it. So the 3 times A is 3A, 3 times C is 3C, and then add 2C to that 3C, and you get 5 children's tickets. On the 3A plus 3C, all I need to do is add 2 to this, so that'd become 3A plus 5C. Okay, so that's how you would modify these two. So let me erase the original, this one, 3A plus 3C. So this is the 2 modifications, that adding 2 more children going on a trip, but not any more adults. Okay, connect it. DeAndre spends the same number of hours awake every day. He writes 365, number of days in a year, parentheses, A minus S, to represent how many more hours he spends awake, A, than asleep, S, in 1 year. DeAndre's mother says that he can also use 365 times A minus 365 times 24 minus A. What information is in DeAndre's expression that is not in his mother's? Okay. Hmm. What information is in his mother's expression that is not in DeAndre? So let me write these out for starters. So if he writes 365, that's the number of days in a year, not counting leap year, and then A minus C. So what does this say that this doesn't say? Okay. Whoops, not C, it's S. All righty. So 365 times A minus S. So awake minus asleep. Okay. Well, A plus S has to equal 24. That's how many hours are in a day. So your entire time is taken up. Either you're awake or you're asleep. Okay. And then 365. So what's not in this is the number of hours in a day, right? It does not say that. It just simply says awake minus sleep, A minus S. It does not say anything about 24 hours in a day where this does. What information? Hmm. So actually, that's what this says. This 365 times awake minus 365 times 24 minus A. Okay. What information is in DeAndre's that is not in his mother's? Um, so it's not number of days, number of hours in a day. Number of hours in a day is what's in hers that's not in his. There's no 24 up here. Okay, so I needed to change that. But what is in his that's not in hers? Well, S. Okay, S equals asleep. They put an A in front of it because you can't have A and awake and asleep. Awake, sleeping. Okay, awake, and an S means asleep, and he has an S where she does not. Okay, and that's that. So close, exit ticket. Noelle brushes her teeth for T minutes twice a day. Noelle uses the expression T times 2 times 365 to represent how many minutes she spends brushing her teeth each year. Write an equivalent expression, then explain what information is in your expression that is not in the expression T2365. Okay. Let me give that some thought rather than you standing here looking at me thinking. Okay, so let's see. Oh, here's one. I could do T times 2 times 52 times 12. Okay, 52 weeks in a year, not times 12, times 7, 7 days in a week. Okay, but there's more than 52 weeks in a year. So anyway, that's one way. That would be an approximation. It's not exact. And you're like, no, there's only 52 weeks in a year. Well, if you take 52 and there are 7 days in a week, 7 times 2 is 14, 7 times 5 is 35, plus 1 is 36. You're missing a day. Okay. Anyhow, it's close enough. We could do that. Or we could just take this and say, 365 times 2 is 730. So you could say 730 times T, the number of times she spends brushing her teeth over 730 brushes. Okay, so either of these two, I guess, would work. All right, that's the end of session 2. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 4, Lesson 16, Session 3, the last session in Lesson 16. There's only 3. Refine. Ideas about reasons for rewriting expressions. Write different expressions for the same situation. Understand how different expressions provide different information about that situation. So here's the apply it. 1, interpret. 2 people describe a regular polygon. Okay, for starters, you need to know what a regular polygon is. So let me go in here and let me choose, see if I can find one. There we go. That right there. Let's just throw this puppy up here. This is a 6-sided figure. 1, 2, 3, 4, 5, 6. That is a hexagon. The word regular means that all the sides are congruent, and therefore all the angles are also congruent. Okay? Whatever those side lengths are, they're all the same. So if this is 5, they're all 5. Okay? All the way around. That's what regular means. Brianna says that the polygon has side lengths of 6.3. Okay? And a perimeter of 31.5. Okay? So I'm going to highlight this stuff. Okay? Brianna says that the polygon has a side length of 6.3 centimeters and a perimeter of 31.5 centimeters. Desiderio says the polygon has side lengths n and perimeter 5n. Which person's description tells you how many sides a polygon has without doing any calculations? Well, it's obviously Desiderio. Okay, because right there, 5n, this being the side lengths, it tells us right there, this has to be number. This has to be, that's an arrow, not a T. This has to be number of sides. Okay? All right. Which person's description tells you how many sides a polygon has without doing a calculation? Well, it was Desiderio. Okay, so I have a 6-sided figure here, so I didn't guess right. What it actually was a 5-sided figure, which is called a pentagon. Okay, so there it is. So let's get rid of this. Okay, so they're talking about a 5-sided figure with side lengths of n. And since it's regular, they're all equal. That's what regular means. All right, next problem. Evaluate. Oh, they aren't talking anymore about that. So let me just double check this. I always like to double check. 31.5 divided by 6.3. Well, in order to divide by a decimal, what we always do is we take a decimal away and make it a whole number and therefore move this decimal the same amount. So it's same as 315 divided by 63. And let's just see if 5 works. 5 times 3 is 15. Carry the 1. 6 times 5 is 30 plus 1 is 315. And look at that. No remainder, which means that there are 5 sides and they're all 31.5 centimeters long with a perimeter of 6.3 centimeters. Okay, so the math works. Okay, imagine that. 2, evaluate. A company sells rectangular pools. Okay. A rectangular pool. Well, I always like to draw diagrams. So here's my rectangular pool. That was just a quick calculation there. The length of each pool is 2 times the width. So if this is W, L equals 2W. So I could call this 2W and this W. Okay. Jelani represents the perimeter of a pool to a customer as 6W. Okay. All right. That makes sense. 2, 4, 5, 6. Let me get rid of this L equals. Okay. So 2, 4, 5, 6. It is 6W. Akiko represents the perimeter with the expression 2. Okay, so 2 times 2W plus W. Well, here's a 2W and here's a 2W, so there's 2 of them, and here's a W and here's a W. So really what you're doing is 2W plus W and multiplying that by 2. And that's what this means. Explain what information each expression tells the customer. Okay. What does 6W tell the customer? This one here tells the customer the length and the length and width can be calculated. And this just tells the perimeter. So I'll just write that like that. 6W just says the perimeter is 6 times the width. Okay, the length of the pool and the width of the pool can be calculated from this if we knew the perimeter. We could find the width and the lengths, or if we knew the length or the width, we could find the perimeter and the other missing. All right. Next problem. All right, so the Spirit Club uses fabric to make school flags for students who wave at a pep rally. The club members want to find the amount of purple striped fabric in square inches that they need for one flag. Avery says they can use the expression 5 times 4 plus 7 times 4, and Pedro says they can use the expression 12 times 8 divided by 2. Explain why both students are correct. Okay, well, let's start with this 5 times 4. Where did that come from? Well, here's a 5 times a 4. So that would find the area of Go Panthers. Okay, plus, I'll change colors. 7 times 4 is telling us that this square here, 7 times this width here, 4. See it right here? So it's this purple. Remember, we're looking for purple striped fabric. So that tells us the area of that. So we're looking for the two purple areas together. This will tell us what each square is. And then when we add them, 20 plus 28 would equal 48 inches squared. So I need 48 square inches to do both purple striped corners. Okay, what did Pedro do? Oh, Pedro took 12 times 8 and divided it by 2. So where's 12 coming from? It's the left side of the flag. Where's the 12 coming from? I'm sorry, 8 is right here. So this is the length and this is the width of the entire flag. And since the yellow and the purple have the same length, 4 inches, and the yellow and the purple have the same width, 5 and 7, then we can just simply add the two sides and find the area of the whole flag, and half of it is the purple stripes. And that's why what they did, Pedro did, was correct as well. Found the total area and divided by 2 because the yellow and the purple stripe have the same surface area on the flag. Okay. Apply it. The expression 6x minus 6.3 represents the perimeter of an equilateral triangle. Okay, so let me get an equilateral triangle. Equilateral, equi means equal, lateral means sides, means the sides are all equal. Every angle 60 degrees because it's also equiangular, and 60 times 3 is 180. Okay, so the expression 6x minus 6.3 represents the perimeter. Write an expression for the side length of this triangle, then draw a triangle and label its sides to represent the situation. Okay, so well, if it is 6x minus 6.3, and that's the entire perimeter, and there are 3 sides that are equal, we can divide both pieces by 3, and 6 divided by 3 is 2, and 6 divided by 3 is 2.3 divided by 3 is 1. So the expression for one side is 2x minus 2.1. So this would be 2x minus 2.1, 2x minus 2.1, and this side is 2x minus 2.1. Okay, so I've done that. I'm going to erase the angle measures though, because we're not talking about those right now. I just was stating other facts. So now that we've done that, part B says, write an expression to represent the triangle's perimeter as the sum of its side lengths. Well, that would be 2x minus 2.1 plus 2x minus 2.1 plus 2x minus 2.1. I'm going to put these in parentheses just to show that they're each side. Okay. Then write an expression to represent its perimeter as a product. Well, how many of those is there? There are 3, so that'd be 3 times 2x minus 2.1. Okay, and that's what product means, multiply. Okay, part C. Why might you want to represent the triangle's perimeter with one of the expressions you wrote in part B rather than 6x minus 6.3? Okay, well, if I wrote it in this way instead of this way, up here, instead of this, it would be because I wanted to find one side length without dividing by 3 from the total perimeter. Okay, so that's why you might want to do that, just to know one side length. Close exit ticket, math journal. Look at the figure at the right. The expression 9 times x plus 3 represents the area of the figure. 9 times x plus 3 minus 6x. Okay, I agree with that. Okay, explain one thing that this expression tells you about the situation. Okay, well, 9 times x plus 3 is the area of the entire rectangle. And what do I mean by that? Well, that's the area. Whoops, let me thin that out a little bit and let me use blue instead. That tells us that the area of this entire thing right here is 9 times 1.5, and 1.5 is 3 plus x. That's where that x plus 3 comes from. That's the width. So 9 is the length. This is the width. So length times width is the area of the entire rectangle. Yeah. Okay. Explain one thing that the expression tells you about the situation. Well, this minus 6x, the minus 6x is the cut out portion. Okay. So with this minus 6x, that's what it's telling us about the situation. We're taking an entire rectangle, but then we are subtracting this rectangle here, which does not exist. Okay, they cut that out, which is 6 by x, so 6x. Okay, and we're subtracting it from the area of the entire rectangle. So it says, then write an equivalent expression for the area. Okay. All right, so how are we going to write this expression for the entire area? Well, if I distribute the 9 times x plus 3 minus 6x, if I distribute here and here, that's going to be 9x plus 27 minus 6x. And then when I combine like terms, 9x minus 6x is 3x plus 27. And then I can further factor out a 3 here and get x plus 9. Okay. All kinds of stuff going on there. Explain what information is in your expression that's not in this one. Well, let's see. What is in mine that is not in theirs? There is three times x plus 9. This plus this times 3 is the area. That's just coincidence. I don't know if the way I did it, there's anything else that it has that it didn't have before. The other thing we could do is break this up. And we could write it like this: 2 times 1.5 plus x, that's the width, times 9, which is the length, length times width. This tells us the length of this side here, and it tells us the length of the cutout. So I guess I'll go with that instead. So 9 times the quantity, 2 times 1.5 plus x. Okay. Let's leave it at that. Okay, so that was the exit ticket. So this is the end of lesson 16, session 3. Thanks for watching and have a great day.